Hello students, welcome to my class. In our previous class, we have studied real numbers, its introductory part, its important property, Euclid's division lemma, and its application, how to find the HCF of two positive numbers. In today's class, let us see few examples where we will apply Euclid's division lemma. See first example, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. So we'll see how we will solve such type of question by applying Euclid's division lemma. So first we'll take let a be any positive integer. Let a be any positive integer and b is equal to 6. We will take 6 here because we need to prove any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. So we are taking b as 6. Then by Euclid's division lemma, there exist integers q and r satisfying the relation a is equal to bq plus r. Here b is 6, so we can write a is equal to 6q plus r, where 0 less than or equal to r less than 6. Here the divisor is 6, so the condition for our remainder is 0 less than or equal to r less than 6. Since we have this condition, the possible remainders are what are the possible remainders? 0, this is the range, so 0, 1, 2, 3, 4 and 5. So the possible values of r are 0, 1, 2, 3, 4, 5. Now we are going to substitute these values in this equation in Euclid's division lemma. This equation we will substitute. So when we will substitute r equal to 0, we will get a is equal to 6q plus 0, that is 6q. So for r equal to 0, when you substitute, we will get a is equal to 6q. The same way, when you substitute r is equal to 1, you will get a is equal to 6q plus 1. When r is equal to 2, we will get a is equal to 6q plus 2. When r is equal to 3, we will get a is equal to 6q plus 3. When r is equal to 4, we will get a is equal to 6q plus 4. The same way, when r is equal to 5, we will get a is equal to 6q plus 5. So these are the possible values of a. When you substitute r, different values for r, we will get different values of a. Out of these 6 values of a, if you see this one 6q, we can write this as 2 into 3q. Since it is a multiple of 2, this is an even number. The same way, if you consider this a, this value of a, here also we can write it as 2 into 3q plus 1, which is again an even number. Now, for this value of a, again we can write this as 2 into 3q plus 2. This is also an even number. So these 3, out of the 6 values of a, we have these 3 values are even numbers. So what are the remaining values? The remaining values what we have is a is equal to 6q plus 1, a is equal to 6q plus 3 and a is equal to 6q plus 5. So these 3 are odd numbers. So we can say that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Now let us see another example. we will see the second example. Here the question show that the square of any positive integer is of the form 3m or 3m plus 1 for some integer m. Like our previous question, here also we will take, let a be any positive integer and we'll take b as 3. We'll take b as 3. Since we have to prove the square of the positive integer is of the form 3m or 3m plus 1, we will take b is equal to 3. Then by Euclid's division lemma, there exist integers q and r satisfying the relation a is equal to, here b is 3, so we can write a is equal to 3q plus r, where the condition for r is 0 less than or equal to r less than 3. So here the positive values of r are 0, 1 and 2. Now in the question what we have to prove is square of any positive integer. So we will take the square of the number a. So a square is equal to 3q plus r the whole square. We will expand using the identity a plus b the whole square. So you will be getting 9q square plus 6qr plus r square. So this is the square of the number. Now we will take each case when r equal to 0, what is the form of this a square, we will check. So case 1, when r is equal to 0. So we will simplify now a square. Here in the expression of a square, we will substitute r is equal to 0. So these two terms will vanish and we will get 9q square. So a square equal to 9q square, which we can write as 3 into 3q square, and this 3q square we will denote by m. So we will get 3m form where m is equal to 3q square. So in the first case we got the square of any positive integer is of the form 3m. Now we will go to the second case, case 2, when r is equal to 1. When r is equal to 1, what is a square value? So here in the a square value, we will substitute r is equal to 1. So a square is equal to 9q square plus 6q into 1, that is 6q plus 1. Here if you see, from the first two terms, we can take 3 common. So we will get 3q square plus 2q plus 1. Here this expression we will denote by m. So we got the form as 3m plus 1, where m is equal to 3q square plus 2q. Now case 3. Case 3 is r is equal to 2. When r is equal to 2, we will see what is the value of a square. When r equal to 2, we will substitute here. So 9q square. When you substitute r equal to 2, you will get 12q and this r square will become 4. Now how we are going to express this? So this expression we will write as 9q square plus 12q plus 3 plus 1. Here from the first 3 terms we will take 3 outside. So 3 into 3q square plus 4q plus 1 plus 1. So here this expression is m. So we can write this as 3m plus 1. So in each case, if you see all these 3 cases, we got in first case we got the form a square is of the form 3m. In case 2 we got a square is of the form 3m plus 1, and in case 3 we got a square is of the form 3m plus 1. So the square of any positive integer is of the form 3m, either 3m or 3m plus 1. Thank you students.